Hi class, this is lesson 10.5, other angle relationships in circles. So we've got one more theorem here. It's in a tangent. If a tangent and a chord intersect at a point on a circle, so right here, we've got a chord and a tangent intersecting right here at this point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So then this angle 1 here is half the measure of this arc AB. And then angle 2, right here, this angle, is going to be half the measure of this arc, this major arc right there. So half the measure of arc BCA. Or you could call that arc ACB as well. So let's use this idea. It says find angle and arc measures. So for example 1, line M is tangent to the circle. Find the indicated measure. So we want the measure of angle 1, which is this angle right here. And I know this arc is 32 degrees. So the angle is going to be half the arc, so I can just do half of 132 degrees. Half of 132 is 66 degrees. Right here we want the measure of arc FED. So my angle is 110 degrees, my arc is going to be twice that. So I can say 2 times 110 degrees, which is 220 degrees. So try this one on your own. Okay, we want the measure of arc ACB, so arc ACB is right here, and it's related to this angle. That angle is 120, so twice that will be 240. So we're going to say 2 times 120 degrees, which equals 240 degrees, and that is my measure of arc ACB. Okay, we got another theorem here. This one is theorem 1012. The angles inside the circle theorem. And we're going to call this our bow tie rule. Let me call it that just because looking at the picture, kind of looks like a bow tie right there. And when we have this picture of a bow tie inside a circle, we're going to follow this rule right here. So it says, if two chords intersect inside a circle, so we've got our two chords intersecting right here, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if I want to find angle 1, it's going to be half of this arc plus this arc. Angle 2 is going to be half of this arc plus this arc. So the measure angle 1 equals half the measure of arc DC plus the measure of arc AB. The measure of angle 2 is going to be half the measure of arc BC plus the measure of arc AD. Okay, on the next page here, we've got theorem 1013. The angles outside the theorem are outside the circle theorem, and we're going to call this our alligator rule. Just because I think it kind of looks like an alligator trying to eat the circle. So for this one, it says, if a tangent and secant, two tangents or two secants intersect outside a circle, so we have our intersection here, or here, or here, then the measure of the angle formed is 1/2 the difference, so subtracting, of the measures of the intercepted arcs. So for all of these pictures, see here we have a tangent and then going a secant. Here we have two tangents. Here we have two secants. For all of these pictures, to find this angle inside, we're going to do half, see it's all half, the big arc minus the small arc. So this angle is half the big arc minus the small arc. This angle is half the big arc minus the small arc. So the trickiest part really about these last two theorems is making sure you get them right. So that's why you're going to want to look at the picture and say, is that the bow tie rule or the alligator rule? So 2A, example 2A, it says, find an angle measure inside a circle. So example 2A, find the value of x. So looking at this, well, that's our bow tie rule. So I know this angle is going to be half this plus this. So I'm going to do half of 112 plus 140. If you put that into your calculator, you'll find that x equals 126 degrees. This picture, looking at it, that's not a bow tie. It looks like an alligator. It looks like it's trying to eat it. So my angle here is going to be half of my big arc minus my small arc. So x, oops, I need a pen. X, try it again, x equals half of my big arc, 170, minus my small arc, 72. So x equals 49 degrees. So let's look at these last three here. And again, you got to ask yourself, is it a bow tie or an alligator? So looking at this picture, really it crosses in the inside. It looks like a bow tie. Even though these lines keep going, it's going to be definitely a bow tie. Okay, so my angle measure here is 52 degrees, but I've got these two outside angles. So I really want to look at either this angle or this angle. But since this is 52, and this is a straight line, I can figure out what this angle measurement is here by subtracting from 180. So that angle measurement that I want is really 180 minus the 52 degrees, and that's going to equal half of the sum of my two arcs. So 180 minus 52 is 128, and that equals half of the sum of my two arcs. So to undo 1/2 times that, I'm going to multiply both sides by 2. So I have 256 equals x plus 144. Subtracting 144 from both sides, I'll find that x equals 112 degrees. So we kind of, for that one, had to look. We knew these two arcs, so we needed to have one of these two angles. Knowing this and that this adds up to 180, I was able to find that angle I needed as being 128. Okay, looking at this picture, is it a bow tie or an alligator? Well, it's definitely an alligator since it's outside of the circle. So we know our angle is half the big minus the small arc. So I can write the equation. My angle, 26, equals half my big arc minus my small arc. So to undo that 1/2, I'm going to multiply both sides by 2. Gives me 52 equals y minus 30. Adding 30 to both sides, you have y equals 82. And that's going to be in degrees again. And looking at the last picture here, is it a bow tie or an alligator? Well, this last picture is definitely an alligator because it touches outside of the circle. So let's see here. We've got two right angles. We know this is A. This one right here, we're going to subtract from 180. This one, this example problem, we're going to have to use something a little bit different. Since this is a right angle, we know this side is 4, and we know this little piece is 2. We know this piece is 4 as well, so that piece is 6. So I'm going to put a 4 here. So this is 4, this is 4. And my total here is 6. So let's draw that triangle out here. So here's a right angle. This is 4. My hypotenuse is 6 here. I need to really know this angle measurement in here in order to solve this problem. So in order to find this angle measurement right here, well, I know this is the hypotenuse, and this is my adjacent side. So I'm going to use cosine. So I'm going to say the cosine, I'll do this in a different color so it doesn't get mixed up with the blue right above here. So the cosine of my angle equals adjacent, which is 4, over hypotenuse, which is 6. So to undo that cosine and to find my angle, I'm going to do inverse cosine to both sides. So if you put into your calculator inverse cosine of 4/6, you'll find that your angle measurement is 48.2 degrees. And I'm actually just going to stop right here. We found our angle measurement for half of angle C, but we're definitely not going to have one that is this difficult or complicated on the test. So I'm just going to kind of ignore this example problem. Let's not worry about it. Don't be frustrated if you don't understand that one. So we're going to stop right there. Make sure if you have any questions on the lesson, you ask me. Have a great day.